everyone, my name is Nurfara Shakira with the matrix number 08 DEU 22F 1110.
My name is Umi Kalsum binti Abdullah Sahidi and my matric number is 08 DEU 22F 1108.
Hi, my name is shameera binti Muhammad Hanifa, matrix number 08 DEU F 221114.
Now, what is trigonometry? Trigonometry is the study of the relation between the side and angle of right angle triangle. Does help in finding measure of unknown dimension of a right angle triangle using formulas and identities based on this relationship. It is the branch of mathematics concerned with the relativities of triangle sides and angle as well as relative function of any angle. There are 6 functions of any angle. They are often utilized in trigonometry. Their names and abbreviations include sine, sin, cosine, cos, tangent, tan, and cotangent is cot, secant is sec, and cosine is CSC. Now, how trigonometry is used in architecture. In architecture, trigonometry is used to calculate structure height, like angles, exact intersection angle, whether you're building an arch, dome, roller coaster, or suspension bridge. Trigonometry will assist the architect in creating a self-model mathematical representation for a builder. It enables the calculation of space and force related with angular features in design.
Next thing we need to know are the basics of trigonometry. First of all, getting to know the hypotenuse, opposite, and adjacent is very easy. In a right triangle, the hypotenuse is usually the longest side, which is labeled as H. They are usually tilted, while the opposite side is the one across from the hypotenuse. They are usually straight. And as you can tell, adjacent is usually the base of the triangle, labeled as A. Next thing is learning how to divide using the trigonometry formula, which are SO, Ka, and TOA. SO means sine equals to O divided by H. Ka means cos equals to A divided by H, while TOA means tangent equals to O divided by H. So Ka and TOA are frequently used in trigonometry to find the angles and the height of the triangle.
Alright, let's go to question number 1. Alright, an architect wants to build a slide. 2 sides and an included angle are given. Find C. So the architect wants to find the length of C. Before for the question, so in this question we need to use cosine rule for find the length. So we will use the third cosine rule. Alright, so we know that the length of C to A is 6 meters and the length of C to B is 2 meters. And we know that the angle of C is 30 degrees and the angle of B is 90 degrees. So C square equal to 2 square plus 6 square minus 2 times 2 times 6 times cos 30 degrees. So now we want to eliminate C square. So we use square root. Okay, the answer C equal to square root 2 square plus 6 square minus 2 times 2 times 6 and then cos 30 degrees. So and then you will get the length of C is 4.38 meter.
Now, the next question. Figure 10 minus 20 presents a very large step that is 10 meters from the building's base and forms a 60-degree angle. When measured from the ground to the top of the building, Mr. David wants to use these stairs to get to the top of a building. What is the building height? So, the solution is adjacent is 10 meter and the theta is 60 degree. So the height we assume is h. So if we need to find the height, so we use the formula tan theta is equal to opposite over adjacent. Tan 60 degree is equal to h over 10. We calculate the tan 60 degree is we get the square root 3 of is equal to h over 10. So we move 10 then to calculate the h. So h is equal to square root 3 multiply 10. So the height of the building is approximately is h is equal to 70.3 meter.
Let's move to the question. So, this is the question. One Rukia asks her student to find the area of triangle of a building that looks like a triangle for school project. The next day, Ali went out and found Menara B and B or Menara 118. Given that angle of A 95.7 degree, B 2 cm and C 3.5 cm. Using the formula given, find the area of triangle. Figure this out with me. Line A to the P or C is 3.5 cm, where A to the C or P is 2 cm, angle A 95.7 degree. Using the formula given, 1 per 2 BC sine A. 1 per 2 equals 2 equals 3.5 sine 95.7 degree. And lastly, we found out the answer 3.483 cm. And this is how I found area of triangle using Sa's theorem.
On to the last question. A radio station tower was built in two sections. From a point of 87 feet from the base of the tower, the angle of elevation of the top of the first section is 25 degrees, and the angle of elevation of the top of the second section is 40 degrees. To the nearest foot, what is the height of the top section of the tower? As you can see, there are two triangles that we need to find. Let's highlight the numbers of the larger triangle first. As you can see, we have the values for opposite, which is 40 degrees and 87 feet for adjacent. O and A can apply to TOA. Since the angle is 40 degrees, let's put tangent 40 equals to B divided by 87. We must make B as a subject because we are searching for it. When tangent 40 is divided by 87, we get the value of 73 for B. Moving on to the smaller triangle, we use 25 degrees instead of 40, which is given in the diagram above. When tangent 25 is divided by 87, we can get the value for A, which is 40.56 feet. Lastly, to find the difference between A and B, we must minus the values together. 73 minus 40.56 equals to 32.43 feet. Now that is how we apply the trigonometry formula in architectural buildings.
In conclusion, we realize that trigonometry can be used in many areas, such as astronomy, architecture, and more. Moreover, without really climbing a mountain or tree, we can find the height easily with trigonometry. They can be used so widely in real-life application, and it's very useful for astronomer and architecture. We can conclude that without trigonometry, life will be so difficult.
Alright, you guys can do this exercise.